Once we have calculated the graphs, the next step in the picking workflow is the filament calculation. Back again in our project, let's have a look at the fills protocol. As you can see, it presents 4 tabs with different data that needs to be filled. In the first tab, we only have to provide a pointer to the previous graphs protocol executed. Then I have the source and targets tabs, which are twin tabs, but they represent different working areas in which the filaments are going to be calculated. The source, in this case, is set to label 1. If you remember from previous video, label 1 was label obtained in the PySeg for the membrane area. And then we have to fill some parameters like the Euclidean distance to membrane and the range of calculation. In this case, we are moving from minus infinite to infinite, and then we are using the refinement tab to specify the specific ranges in which we are expecting to get the results. So there's no help here because we think that the labels are self-explicative, but if not anything, just write a mail to Scipion team and we'll be very pleased to answer any question. Okay, so the targets is the same. What it is important to have here in mind is that in this case we are working from the in-membrane zone to the other surroundings of the membrane, labeled in the PySeg with label 3. The rest of the parameters are the same, and now it's time to go to the refinement tab. Here we have to select if the orientation of our particles respecting to the membrane are pointing in or out, and then we have to refine the filament geometry, specifying a range of Euclidean distance, geodesic distance, and their rate between both of them, because the geodesic distance is curved and the Euclidean distance is straight. So this sinuosity rate, filament sinuosity, represents the difference between the ratio in terms of curvature of one respecting the other. At this point I could execute. Before that, let me also talk about this parameter. The wait for is used in this case for long executions. For example, imagine you are going, you have to leave, it's the end of the day, and you are executing the graphs with identifier 1139. I can prepare the fills protocol, fill in all the required parameters, add here the identifier of the previous protocol, in this case the graphs protocol, and execute it. Using this functionality, this protocol will be waiting to this one until it's finished to begin its execution, and I can do it consecutively, for example with the picking, and this is exactly what I did to get this project. So if I would click in execute, after some time I would get the results. In the case of my machine, spend time was a little bit more than an hour, and the obtained results again can be observed using the 3D viewer. Let me click on analyze results and choose this one, for example. And now we can observe a different information. Again, the tomogram and the slice mode, just to see tomogram, to click on the different orientation of the slice for cutting the data, and we can rotate again. This easier without the slice mode, but we can do it all together. And if I represent the net, this is for now the filament representation considering the parameters used as inputs. So this is very useful to check in a very visual way if the parameters introduced were the correct ones and we get the information in the regions we are expecting it to be. Again, we provide some different metrics to visualize different information from the calculated filaments, for example, the filament length. And that's all for the filament calculation. Let's move now to the picking.